Hello, my name is Marcelina Lirius and welcome to Math Monday. In this video, we're going to focus on the Algebra 1 standard on interpreting functions, which is A1 IF A2. Use function notation to evaluate functions for inputs in their domains and interpret statements that use function notation in terms of a context. So before we get started, please be ready with your supplies. You will need your pen, your notebook, and if you have a calculator, that would be helpful. Okay, let's start. When we say function notation, we have the notation y is equal to f of x, wherein x is the input, y is the output, and the name of the function is f. Okay, so if we have y as the output, x here is the input, which we also call as the independent variable. Y is the dependent variable, and the function, the name of the function is function f. Okay, that's the function f. So in our previous videos, we have seen the equations. Let's say y is equal to 5x minus 3. If we use function notation to represent y is a function of x, or y is equal to f of x is equal to 5x minus 3. So notice that this function is expressed in terms of the variable x, which is the independent variable. Okay. Now let's move on to evaluating functions. So given f of x is equal to 5x minus 3, we are asked to find the value. Means evaluating means find the value of the function when the variable x is 2, or when the input is 2. So we have f of x equals 5x plus 3. So we find the value when x is 2. So we're finding f of 2. So replace x with 2 in the function, then plus 3. So our f of 2 is 5 times 2 is 10 plus 3. Then our final answer is 13. So f of 2, or the value of the function when x is 2, is 13. Okay, next. So when we are asked to evaluate the function when x is 1/5, okay, x is 1/5 here. So this simply means that we substitute, okay, in the function f of x, so that means x is 1/5, is 5 times x. So our x is 1/5 plus 3. So this is our 5 times x plus 3, and that is the function value when x is 1/5. So simplifying, so we know that 5 over 5 is 1 times 1 will give us 1 plus 3. Then the function value is 1/5. I mean, function value when x is 1/5 is 4, okay? So that's the value of f when x is 1/5. Okay. In our next example, we're going to interpret statements that use function notation in terms of a context. So an online face mask company's monthly production cost is represented by the function cis of x equals 7,000 plus 1.75x, with $7,000 as the fixed cost. And the company also spends $1.75 for each mask that is produced. So this is the variable cost or the production cost per mask. So we are asked to find the total cost if 20,000 masks were produced in October. Okay, so if the total cost is 20,000, so C of X equals 20,000. So a middle school debate team sold cookies as fundraiser for their trip to Washington. The function P of X equals 12X minus 15 was used to determine the profit P from selling X boxes of cookies. So we are asked, what does P of 100 mean? So remember that P of X is the profit function. So when we have P of 100, okay, this expression P of 100 tells us the profit, okay, this is the profit when 100 boxes of cookies are sold, okay? 100 boxes of cookies are sold. That's how we interpret P of 100. Then in letter B, we're asked how much profit. So if we have P of X is equal to 12X minus 15, so we're asked how much profit, okay, what is the amount of profit if 300 boxes of cookies were sold? Okay, so the profit is equal to 12. When X is 300, we substitute X with 300, then minus 15. And if we simplify this, okay, help me out on the computation, please double check. 12 times 300 is 3,600. Bring down, okay, minus 15. And simplifying, this will give us 3,000, okay, 585. So our interpretation, the profit earned, okay, when X is 300 is $3,585. Okay. In letter C, we're given that the team earned a profit of $2,385. So we're already given the profit, 2,385. This time we are asked for the number of boxes of cookies that were sold. So what is X? So our profit function is P of X equals 12X minus 15. So when the profit is 2,385, we are asked for X. Then minus 15. Solving for this equation, we eliminate minus 15 by adding 15 on both sides. And this will give us 12X equals 2,400. Please double check my computation. And by inverse operations, again, we divide both sides by 12. This cancels out. 12 over 12 is 1 times X will be X. And 2,400 divided by 12X is equal to 200. Our interpretation, again, so when X is 200, that means the profit earned by this team is 2,385. Okay, let's have another example. An online face mask company's monthly production cost C is represented by the function c of x is equal to 7,000 plus 1,000 plus 1.75x, where 7,000 is the fixed cost and the company spends $1.75 for each mask that is produced. So we are asked to find the total cost if 20,000 masks were produced in October. So if our c of x is equal to 7,000 plus 1.75x, and when x is 20,000, so that means our function notation is c of 20,000 is equal to 7,000 Okay, let's have another example. An online face mask company's monthly production cost is represented by the function c of x is equal to 7,000 plus 1.75x with 7,000 as the fixed cost, and it spends $1.75 for each mask that is produced. So for letter A, we're asked to find the total cost if 20,000 masks were produced in October. So given c of x equals 7,000 plus 1.75x, we are asked what is the cost when x is 20,000. Okay, so using function notation, so c of 20,000 is equal to 7,000 plus 1.75. Again, we substitute x with 20,000 here. Simplifying, so if you have your calculator, help me out with this. If you multiply 175 times 20,000, double check my computation here. So this should give us 35,000. And this means that the total cost of producing 20,000 masks denoted by c of 20,000 is $42,000. Okay. You can take down notes. In the second example, in the second item, we're given that if in September, the company spent 33,250, how many masks were produced? So we're given that the cost C is 33,250. So this means that we just equate the function. This is 7,000 plus 1.75x. Okay, then we solve for x. So we're going to subtract 7,000 from both sides to eliminate 7,000 here. And this will leave us $1.75 x on one side. And here it will be 26,250. Again, please double check my computation. By inverse operations, we solve for x by dividing both sides by $1.75. And this gives us now x is equal to 15,000. So this will be the number of masks that will be produced if the company spent 33,250. This ends our session for today, and I hope to see you next week.